Welcome back, guys. I hope you enjoyed the Bernoulli's principle and its application concept. So there's some last 1 minute or 2 minutes it become hurry because late night I done that. So applications I'll go slowly and let it be take much time. So we'll discuss one by one neatly. So FAG, so like tunnel. This is one tunnel shape or conical shape of different areas. And density of the liquid is equal to 1.25 into 10 power 3 kg meter cube is given. Means it is glycerin. And pressure drop between these 2 points, first point and the second point, pressure drop is given 3 Newton second, 3 meter per sec, minus 2 Newton by meter square Pascal, 3 Pascal second go. Is asking rate of flow. So the rate of flow means AV. Rate of flow means small a into V you can find out here, or capital A into V1. If you take this is V1 here and V2 here. So if you remember, I have given some formulas according to Bernoulli's principle, application of pressure energy, sum of three energies at two different points, we will get V1 is equal to, means the velocity at the first point is equal to A2 root over 2gh by A1 square minus A2 square. Or, so in the place of 2gh, I can write pressure difference. Here is given pressure drop is given P1 minus P2. So that is equal, I can write A2 into the root over 2 of P1 minus P2 by rho into A1 square minus A2 square, or A2 square minus A1 square. Which one is bigger? That will subtract here, no problem. So these are the two formulas. If I want to find out V2 here, the velocity V2 is equal to A1 will come here. The remaining are similar. So volume flow rate means, or rate of flow means amount of water or rate of flow, both are same. AV we have to find out. A1 V1 or A2 V2, that is your case. So all values. So according to Bernoulli's, between these 2 points, pressure difference P1 and P2 is given. So when pressure difference is given, P1 minus P2, that is H rho g. The pressure difference is H rho g, because here it is exposed to atmosphere at point 2 and at point 1 it is exposed to atmosphere. The pressure energy is cancelled, means atmospheric pressure energy, pressure head will be cancelled. So the difference in the pressure H rho g will be there. That is given 3 Pascal or 3 Newton by meter square. So that equal to P1 minus P2 is equal to 1 by 2 change in kinetic energy V2 square minus V1 square. You know, H rho g plus half rho V1 square equal to H2 into rho g plus half rho into V2 square. If this P1 and P2 is the pressure differences of pressure like this, for example, horizontal cone, if you take like this, the conical shape horizontal. So here given means the pressure energy is, difference in the pressure is equal to H rho g, you have to take, like this is given. Otherwise, here like this is given means this is horizontal. So here pressure energy is P1, here pressure energy is P2. H rho g is 0. The difference in the pressure energy. That means the work done PA1, P1 A1 delta X1 minus P2 A2 delta X2, that equal to PdV. That will be the here answer given, P1 minus P2. So if it is taken like this, H rho g will be in the place of P1 minus P2, it will be H rho g. So that's why these two equations I have given, right? So substituting, you will get answer. So in physics, the students has to do only finding the formula, exact formula from the given data. Afterwards, who knows maths very well, they will do the problems correct answer. If you are poor in maths, calculation, simplification, and where you have to multiply, where you have to subtract, and common terms, cancellation, that and all you are perfect means answer will come perfectly. So next model will go. So here there is a one tank with 750 centimeter square and 500 millimeter square areas. So the hole is there at the bottom of this tank. Here at the bottom, extreme bottom of the tank. The tank is in the height H rho g, H from the ground. This is a building. On the building there is a tank. Surface area means bottom top area is area of this tank is equal to cross section area of this tank is equal to 750 centimeter square. And here a small hole is equal to 500 millimeter square. See, difference is given centimeter square, millimeter square. So that will be centimeter square. You have to convert like this. 500 into 10 power minus 2 centimeter square. And here they have given V velocity, the exiting water velocity of efflux is equal to 30 centimeter second was given. According to means is asking to find out the velocity at means dH by dt. So velocity of flow rate means that means velocity of this is what the water depressing rate. This velocity gives the depression rate. dH by dt will give. In some of the questions they will give dH by dt. The rate of change in height. So now after substituting A1 V1 equal to A2 V2. So 150 by 750. So that is 1 by 5 means 0.2 centimeter second. Because all centimeters they have given. If this I want to convert into meters, we know centimeter equal 10 power minus 2 meter. But answer is given like this. So you have to convert. Otherwise 1 by 5 centimeter second is the final answer. We have to verify the answers also, how they are giving. So according to get the answer, we are going on simplification. Otherwise, here itself answer over. 1 by 5 is the answer. Next model. Next problem. So here, the density of one liquid is given. And the areas are given. A1 and A2 are related like this. One liquid is there in one tank or beaker or vessel. The pressure difference between that tank is, that level is 4500 Pascal is given. So this is the given data. So whenever they have given PA minus PB, they can ask flow rate or velocity. Even though they are asking flow rate means you have to find out velocity, then only flow rate will find out A1, V1. So to find out, we know the formula according to Bernoulli's principle, difference in the pressure energy is equal to of rho into A1 V1 square minus A2 V2 square. So A1, A2 values are given. A2 is equal to A1 by 2. Here is substitute. We will get the required answer. So velocity. So here directly I used to find A1 V1 square. A1 V1 I want to find out. So A1 V1. If V1 means by A1 doing, na, you will get V1. So here this model is different. So the tank is given filled with 40 centimeter, up to 40 centimeter water level is there. There is a hole at the bottom of the tank with cross sectional area A, and total the area of the tank is equal to 0.5 meters square. Check here. And here the pressure energy is not atmosphere. There is a 25 kg weight is there on this area of cross section. Therefore, pressure on this is equal to 25 into G, mg by A will come. So apply at A and at B Bernoulli's principle. So this is the answer. Bernoulli's principle means here mg by A plus h rho g at this point A point, h rho g. Plus here, if you neglect the velocity at the top or in the tank, here velocity neglect means 0 will take. Otherwise, this V1 square will bring this side, equation another side. V2 square minus V1 square. There A1, A2 will substitute. Okay. Here both the velocities are not given. Is asking velocity is finding here means no need to convert this A1 V1 is equal to A2 V2. In the case of V2 here this formula is there. In this V2 I am substituting A1 V1 by A2. Otherwise V1 I want to means in the place of V2 I will substitute. V2 I want to means in the place of V1 I will substitute. A2 V2 by A1 I will substitute. So we will get answer in Bernoulli's principle, right? You know, that means pressure energy H1 minus H2 into rho g is equal to the atmospheric pressure is the pressure energy. H1 minus H2 into rho g is equal to 1 by 2 rho into V1 square minus V2 square. That is already, you know. I here very clearly I have given C, A point and B point. Application of Bernoulli's principle, PA energy that equal to mg by A. H rho g here at this point is 40 centimeter height, therefore H rho g will be there, and velocity is neglected here. If not also I will give here what will happen. So 0 I have taken. Then PB, so H rho g and half rho 2 V2 square. This is the Bernoulli's principle at point B. So there PB is equal to 0. Pressure energy is not there. So here atmospheric pressure and here also atmospheric pressure, these two get cancelled, not a problem. Here P naught also you can take, here P naught I can take. H rho g 0, half rho into V2 square. This I want to find out. V2 I want to find out. It means velocity of F flux. So now the same equation when the V1 is not neglected, what will happen? So now pressure difference in pressure energy PA plus H rho g, so is equal to, here PA is equal to mg by A plus H rho g is equal to 1 by 2 into rho 2 V2 square minus V1 square. I want to find out V2 here. This is V second point V2. So V1 I will neglect, that equal to 1 by 2 into rho. So V1 I am going to neglect means A1 square V2 square minus A2 V2, A2 square V2 square by A1 square, because V1 is equal to A2 V2 by A1. So now here all the values remaining, all values A1, A2, everything is given. V2 we can find out. A1, A2 values, density value and mg value, A value, cross section A. Here A means A1 value, H rho g, everything is given. Substitute now you will get. But for simplification, he said neglect velocity at the top. So this is the answer. 3 centimeter second inverse. You can write it is in 3 meter second inverse also. So you can understand, right? So this is another model. So if neglect means not neglected V2 means what will happen? See once. Answer how much will come. So mg by A is 500 already calculated, plus H rho g is 4000 is equal to, so water only na, so 1000, so 500 here again into, so V2 square take common means A1 square minus A2 square by A1. A1 square 0.5 meter square, 1 into 10 power minus 4 meter square. So this is 1 into 10 power minus 4, very negligible. So we can take out this value 1 we can substitute, otherwise we can neglect it, right? So neglect means again rho into V2 square only will come. So we understand this. So V2 square only will come. So I am neglecting this A2 value, means small a square. A2 means 10 power minus 8 is coming, right? A2 square means. So that A2 square can neglect. So here A1 square get cancelled means then V2 only will become. V2 is, A2 is very less will come. A2 is less. Then A2 square is equal to 10 power minus 8 means very less it is. So it will not affect anything. That's why I will go with A2 V2 square neglected. So then I got answer same 500 into V2 square. Then V2 is equal to 3 meter second moles. Hope you understand? So if A2 is not small, very small, then there is a difference in the answer. Otherwise, nowhere. So now next model of problem. Here in this problem you can see. So the problem is like this. So there is two cross sections of flow, the unsteady flow. This is unsteady flow. V1, V2 different means non-uniform and unsteady also. So now pressures are also difference is there. Now that's why it is unsteady. Steady means dp by dt is equal to 0. Already in the flow I have given flow rate or what types of flow I explained that. So unsteady flow and non-uniform also. So now if you take here, acceleration is given here, and here, sorry, acceleration not here. This is the area of cross section is given here, and here area of cross section is a by 2. So when both are given in the same values, meter square or centimeter square, not a problem. Depends on the answer is given meters or centimeter, that is the point. So now here, the relation between V2 and V1 I got by using equation of continuity. A1 V1 equal to A2 V2. So from this V2 is equal to 2V1. This is the relation I got from the equation of continuity. So now he is asking what is the velocity at the larger cross section from the given diagram. So no matter whatever the question, he is going to ask rate of flow or velocities. That's enough. In this Bernoulli's principle, velocity of flux, rate of flow, or maximum height where the hole should be, or range is how much. This type of questions only will ask. There are two different holes. The where the water will strike the ground. Otherwise, from the two different holes, different height, holes at different heights, reaching the same point on the ground, then what are the ratio of heights they will ask. So that questions I will see next. Solve models. Given density is given, density of the fluid flowing to this tube is given. That may be kerosene here. 800 is given means kerosene. The pressure difference also given. P1, P2, pressure energy difference. 4100 pascals. So V1 is asking to take G value as 10 meter second power minus 2. If G value not given, already in the gravitation explained, you have to take 9.8 only. So they will give maximum, they will give 10 only in the fluid statics and all. Don't worry. Therefore, Bernoulli's principle again application. pressure energy given, and here H rho g also there. Not only pressure energy, potential energy also there. Therefore, apply the 1 point and 2 points Bernoulli's equation. Finally, you will get this equation. P1 H rho g plus half rho V1 square is equal to P2 plus half rho V2 square. So, for 1 point and 2 point, you apply. So, here V2, directly I am substituting here V2 value. V2 is equal to 2V1, substituting here. Otherwise, you can substitute in the place of V2. I want to find out V1, therefore V2 I need to neglect. In neglecting V2, so here I got like this, A2 V2 by 2. Means V2 is equal to 2A V1 by A. A2 means A by 2. Otherwise, V2 is equal to 2A V1 by A, that is equal to 2V1. Similarly, that is substitute. You will get answer. So here they are given, they are asking to find 11 by root 12, we got answer. But they are asking like this. So it is root x by 6. So in this way, this one I want to change into in this one. This is my answer. I got answer according to following the Bernoulli's principle and steps. But this answer not given. So this answer they are asking in the form of root over x by 6. They can ask like this. So to asking x value is how much. Then square on both sides. Squaring on both sides. So now 121 by 12 is equal to x by 36. 12 1 ja, 12 3 ja. So 363 will come answer. So this is one answer. One method means squaring on both sides from the given. Otherwise, denominator 6 I want, but I got root 12. So 6 I want to get means in the root denominator should be 36. So this is the method I am following. Root 3 I am multiplying. Above also root 3 I am multiplying. Then it will go under 121 into 3 root over root 63 by 6. That is also one answer. X equal to how much means 363. Next, coming into next question. So the maximum range where the water strikes, then the height of the hole. They are asking here height of the hole is how much. What is the height of the hole, or where hole should be? Hole should to achieve the maximum range. Water strikes. This is the maximum range. That means if the hole is above or below, there is no way to achieve the maximum range. Like in projectile, angle projected with 45, then only the range is maximum for a given velocity. With the same velocity you are projecting the particle less than 45 or more than 45, it will reach the more than 45. It reaches the ground, but not maximum range. 60 means it will reach maximum height and come down. 30 degrees means it will reach less maximum height and at the same way less range also. So maximum range is only 45 degrees. Similarly here, anywhere on this height, on this wall of the beaker or a vessel or tank, you make a hole, the water comes out and strike the ground. So the maximum range from the bottom of the beaker achieved at h by 2 means capital H by 2. H is column of the water in the tank. In that at half distance we are making hole, that will be reached to maximum range. Therefore, H is equal to H by 2, that equal to here 12 meters. They have filled the water in tank. Therefore, required height is equal to capital H by 2, that is 6 meters. So how we will get h is equal to h by 2? The proof I am going to give here. Whatever the problem they are asking, maximum, minimum means. So the x value I want to find out here. The x is equal to, this is maximum when means this is varying with respect to height, right? The water is coming down with from the 12 meter. So with the h. So consider I am making a hole at h meters. So the range is varies with depending on h and varies, right? Minima or maxima, that depends on h value. So in that case, if you take dx by dh, the x, the value we have to derivate with h, which is equal to 0, that gives the maximum range. Let derivate this x is equal to v into t, v equal to root 2gh. From applying the Bernoulli'S principle, you will get v equal to 2gh. Time is equal to root over 2h by g. In this, no doubt. So this will be formula like this. Derivating with x, now we will get h is equal to h by 2. So now next model. So here the train of area of cross section is moving through the another tunnel of cross sectional area 4s, and the constant pressure is maintaining by the train, that is P naught, or pressure difference between the air tunnel, the air moving both the sides of train, that pressure difference between these winds and train is P minus P naught, pressure difference on the train, which is equal to 1 by 2 rho into V2 square minus V1 square. So here V1 means velocity of the train, V2 means velocity of the wind. So now here if we take the winds are moving, means in this this train is there, this gap only winds are moving both the sides. So the area of that gap is equal to 4s minus s. The area of the gap, this is s of the train and 4s of the terminal. Means s is the area of front part of the train and 4s is tunnel, 4 times of s is the tunnel's area. Then gas is filled both the sides of train in area 4s minus s. So that equal 3s. So then V2 will become 4 into velocity of the train by 3 according to this formula. Now substitute in Bernoulli's equation, well known this is, so you'll get answer like this. That is difference in the pressure. So like this, there are many applications are there. Okay, I will discuss more. Consider the water is coming out from the square side of L. There is a whole square side of L with V1 velocity, and there is a circular hole of radius R. The velocity is V2. And here these two are, the water is coming out from this and water is coming from this, both are reaching the same point on the ground. This is the condition, same point on the ground. So now S is equal to, we know formula, S is equal to V1 into T, that is equal to V2 into T, T2, T1. Times also different here. So the square hole is H distance from the free surface, H depth, and circular hole in the 4H depth. The total height is equal to capital H, consider. So then, according to equation of continuity, A1 V1 equal to A2 V2. A1 V1 equal to A2 V2. So here they are asking radius. They are not asking any h value or time value, or from the bottom the second hole is, or square hole is how much height, or circular hole is how much height from the bottom when they are reaching the same point. That is another question, another model. But here is asking what is the relation between R and L, length and L they are asking. They are going to ask R and L areas. So now we know A1, V1. A1 means here area of the square loop, L square. V1 equal to, according to Bernoulli's principle, we will get root 2GH when we are neglecting the dH by dt. That means the velocity of free surface water. Otherwise, it will be dH by dt or V1 will consider. So now A to V2 sub to 2G into H 4H. So you will get this answer. 2GH, H is equal to 4H here, 4 times of H compared to the square loop. Then the radius of the circular hole is the square length by root 2 into pi, root over 2 pi. So this is the answer. Next one. Next question. So here, as we discussed in the above model, these two are, the velocities are coming here with Vp and Vq and reaching the same level from the bottom of the tank, and they have given the Q hole in the distance h and P hole in the distance x. They are not given also, find out this is x. The water filled in the tank up to the level h. Then the P hole in what distance from the ground? That is the question mark here. From the diagram, they are asking the hole P made from the ground in the height h. In the height what? Which is h minus x you have to find out. That is x, h minus capital total height minus from the top it is in the x meters. Therefore, h minus x is going to ask. That is asking. So to find this value, there is only one hope, that is x is same is given and we know. Therefore, S1 is equal to root 2GH into time. Similarly, so this is, here H is given from the Q hole is in the H distance from the bottom. Therefore, total is H minus H. For velocity, H minus H you have to take. For time, H by Z you have to take, 2H by Z. For velocity, it is 2G into H minus H, and time it is root 2H by Z. So difference you find out, heights and equations. Then S value, range value is equal velocity into time, horizontal velocity into time. So you got this answer. Finally, you will get. So finally, you will get here in this equation, we will get x is equal to h minus h by, here after quadratic equation, h minus x or h value will get. Right? So now these are the answers we will get. H value is proportional to h minus h, or h value proportional to h minus x. So this is. Now we are at another question. So the tap. So in water coming from the tap of diameter d, not only in this case, whatever the case, the area of cross section after some distance will be decreased. So here the water is exiting through this area in all the directions, and the same amount is displaced to the h distance also, but the areas will be different. because here it has more potential energy, here it has more velocity, kinetic energy. So means potential energy converting into kinetic energy according to kinematics, energy theorem or energy theorem. So now here A1, V1, A2, V2. Here A1, V1 and here A2, V2. A means pi d square by 4. After substituting the values here, A1, V1 equal to A2, V2. Finally, you get V2 value. Right? Means V2 not is asking to find out D2 value. So to get the D2 diameter value, we know V2 value, right? Here, this one, D value I know, but here I don't know D2 value. D2 value I want to find out. Velocity is given at the highest point, means opening point. Then V2 I don't know. To get the V2 value, Bernoulli's principle will apply. Pressure at A plus H rho G plus 1 by 2 into rho V square. So pressure at A is atmospheric pressure will take. Pressure at B also atmospheric pressure. These two get cancelled. Atmospheric pressure means. Therefore, H rho G is equal to 1 by 2 rho into V2 minus V square. V I want to find out. No, not V. I will find V and I will substitute the here in this equation I will get D value. So here this is V value, equation 1. So here it is equation to A1 V1. Substitute now you will get answer. So this is related to Bernoulli's principle application. Here I will discuss one more question. So next model. So consider one vessel filled with water up to height h. At the bottom of this vessel there is a hole, small area of hole. So here A is very less than A. Then we know V is equal to root 2 GH according to Bernoulli's principle. After application Bernoulli's principle to the point 1 and point 2 we'll get that answer. So now is asking to how much force exerting by this the water which is coming out from this outlet, velocity of efflux on this tank, how much force exerting. So force is equal to MA, I can go here. So force is equal to dm by dt means V. So change in momentum, rate of change in momentum. Therefore dm by dt into velocity, the velocity which is coming here. So this is equal to 2 GH afterwards you can substitute. So dm by dt, that means d by dt of mass of this amount, dm by dt amount, mass of this amount which is coming, that is equal to, I can directly substitute volume into density here, the volume into density and here velocity V. So this is equal to here area into, so here the water is how much is coming. So this is the rate of amount of flow. So this is dH by dt. So V1. So now the area of cross section into dH by dt is equal to velocity into rho into again V, that equal to the rho A V square. Rho A V square. This is the force. In change in momentum also, NLM also we studied the same thing. This is the force is equal rho A V square to rho A V square from the change in momentum. So here V equal to V square is equal to 2GH you can substitute here. So H is height of the 2G into capital H it is. So now for example, because this force is acting in opposite direction on the tank can move in to the opposite direction to the applied force. So the tank should be in a rest position or equilibrium position. there is a friction is there, that is equal to mu mg is equal to rho a v square. So here again m is equal to the total mass of this liquid, that equal to mu into a into h into density into g. So that equal to rho a v square. Rho a and rho a get cancelled. Then v is equal to root over mu into hg. Mu into hg. So this is one formula. So instead of bottom, there are two holes are like this. So these two holes are velocity v2 and here velocity is v1. So the net force will be the resultant linear, L-I-N-E-R, linear. If this force perpendicularly acting, for example, here one pipe is connected like this, here one pipe is connected like this, perpendicular means perpendicular to the distance and anti-parallelly they are acting, and like parallel forces are acting, then torque will come. This will be rotate. This vessel will be rotated. But here I am not going to discuss that one. So this is coming velocity v2 outside and v1. So it is very clear. The v1 is equal to root 2 gh1. v1 is equal to root 2 gh1, and force 1 is equal to the rho a into v1 square. Already in this example I have given. So this is condition. Coming into v2, if you apply Bernoulli's principle, you will get v2 is equal to v2 square equal to root over 2g into h plus h1, you will get total height h plus h1. So from the given data. Sometimes they will give some height from ground and total height they will mention. The total height minus height from the ground neglect means here you can substitute h plus h1. Now f2 is equal to the rho a into v2 square. Therefore net force is equal to f2 minus f1 or f minus f2. v2 is more, that's why f2 minus f1 I can go. That equal to rho a into 2gh plus 2gh1. So v square, rho a v square, minus f1 is equal to rho a into v1 square 2gh1. So the remaining answer h1 get cancelled. 2 rho a gh. So this is the f net when two holes are there. This f net into perpendicular distance is equal torque will come. This into perpendicular distance. For example, this is given width of the, or this is the diameter of this one is equal to d is given means we will substitute. Otherwise, this f net is equal to mu mg, you can substitute. So that is another mode. So next one. So here total reaction force, same formula, but here the condition is the density is, so in the above two diagrams, the area of cross section is defined. But for example, here in the distance x from the surface below, there is a small slit that is equal to dx. A small slit. So there is a dx hole, small hole or slit, small dx will be there. Then what is the reaction force? The total reaction force how much? Jai Sri Rama. So in that case, so due to this small slit, the force is equal to df is equal to the force due to this small slit is equal to same rho a v square. Rho into a is equal to b into dx. V square means 2gx. So now f equal to 0 to f integrating, and here this x is varying from So this is how much? So here h is there and total height is equal to h, capital H. Therefore x is varying to h minus h2. This is h minus h2 h. So now the rho 2 rho g into b width integral h minus h to capital H x dx. So that equal to x square by 2. So now this will be take common. So finally the reaction force is equal to, so after substituting this is, and the LCM we are taken. So the final formula 2 the rho g into b means 2 get cancelled, square is coming and 2 is no need to take, rho g into b of 2 into capital H minus small h. So 2 will not come, rho g into b 2 capital H minus small h. So this is reaction force on tank by the small slit or small hole. So this H value is given, we can substitute that value. So next model of the question. So up to H, the liquid is filled up to H height in that vessel, static fluid. So now the hole is opened in this way, in this direction with angle some theta. So V2 is very nearer to the ground considered, theta is small, V2 is very nearer. So apply the Bernoulli's principle to 1 and 2 point. This is the second point. This is the third point considered. So for Bernoulli's principle 1 and 2, we will get V2 square is equal to 2GH. So after solving that. Now Bernoulli's principle for 2 and 3, for 2, if I apply for 2, P naught atmospheric pressure plus H rho g 0 plus 1 by 2 rho V square is very nearer to ground, I will take rho into V2 square is equal to, here P naught again plus Y rho g, Y is the distance, Y rho g plus of rho into V3 square. So now it is very clear V3 is equal to, according to projectile motion, V2 cos theta. Now Y rho g is equal to the rho by 2 into V2 square minus V2 square into cos square theta. So rho get cancelled. 2yg is equal to V2 square into sin square theta. V2 square into sin square theta. So now V2, if I substitute here 2gh, so here y is equal to how much I will get? So here V2 value, this is equation 1 consider, this is equation 2. So substitute 1 and 2, then h is equal to, means y is equal to, so in the v square 2g get, means y is equal to h into sin square h into sin square theta. So now y is equal to h when sin square theta is equal to maximum, that equal to 91. Then y is equal to h. So in this case here, it is not y is equal to h. Theta is not 90, some less than 90. The theta is less than 90, then y will be less than h. H is maximum. So y cannot exceed or reaches to h. Y will be less than h only. So I hope these are the models. There are many types of models are there. Everywhere different points you have to consider. Bernoulli's principle you apply, you will get. So now next model and the next type of problems I will give on YouTube and aeration of the fluid. Two more videos I will post on fluid statics. Thank you, everybody. Thank you.